Cédric Waldburger. We are going to talk about the internet computer, Web3, and everything from a beginner's perspective. I didn't do a deep dive yet on the internet computer, and Cédric is really deep in the topic. So Cédric, welcome to the show.
Thank you. Thanks for having me. I'm excited. And I think this is a great way of exploring a topic, just doing it out in the open, seeing what questions others have. And so pretty excited about this.
Yeah, because in the first place, I think we wanted to do it privately. And then I had the idea, why not to do it in the open? And I think that's actually a really good idea. So we documented. I think a lot of people are in the same spot. Maybe they have heard about the internet computer, maybe not. We're gonna start from the beginning. So just tell us in a nutshell, what is it and why should we care about the internet computer?
All right, so I'll try to keep the nutshell pretty small for a start, and then we can dive deeper and go down the rabbit hole. But I think for me, the number one question why you should care about all these blockchains and all the different types of decentralized platforms that there are is because of decentralization. I think this question, does decentralization matter, is a very interesting one. And before I give you my take on why I think it does matter and how I perceive decentralization, it'd be interesting to hear from you, and maybe if some people want to leave their ideas in the comments as well, that'd be great to see. But like, if I ask you, does decentralization matter, it'd be interesting to have your answer.
Absolutely, it matters. I mean, we see that centralization creates trust problems. It creates control problems. Of course, you know, I'm a big Bitcoin fan, so I'm all about decentralizing the old financial system and recreating creating a new version of the financial system. So I'm fully on board regarding decentralization. Of course, it doesn't make sense probably for all applications, but in general, I think something that is decentralized is more resilient, more stable, and isn't abused as easily.
And so I think with 99% of what you said, I fully agree with. One thing that stood out to me is that you said it probably doesn't make sense for all applications, right? And I'll be curious to hear where that came from for you. But what I typically see is that people say something along those lines. It probably doesn't make sense for everything if they realize it comes at a cost. And the cost nowadays usually is it's gas fees, it's complexity, getting the users onboarded. And if all of that wasn't the case, then we probably say, yes, everything should be decentralized, because decentralization, and this is my answer, if you could quickly enable the slides, I quickly want to jump in.
Of course, and we also have a comment by Danny. He said it would be great if we would record this session. And yes, good news, this session is recorded on YouTube, on Cédric's channel, on my channel. So you will be able to watch it later, and I will also upload it on Spotify and all the other podcast platforms. And again, if any in the audience has any questions or comments, feel free to engage with us. So I'm enabling your slides. So show us what you have.
Thank you. Yeah, so this is the question that we just tried to, or that you answered. And my answer is, it matters because it gives us really nice qualities. And you've mentioned some of this. If we use decentralized technology, it makes whatever we apply it to, if we use decentralization as a tool, whatever we apply it to, it makes it more transparent. It makes it, to a large degree, immutable. It often increases censorship resistance. It provides trustlessness. And something that I think you said as well, it allows us to build things more efficiently because we take out a middleman. And there's probably 10, 15 other components here, or qualities that we gain from decentralization that aren't listed here, but are kind of along the same lines. And all of these are generally positive. Now, of course, not everything should be censorship resistant, right? There are certain things that we want to govern, whether that's decentralized governance or centrally governed systems, but not everything needs to be on the internet. Not everything needs to be immutable. But in general, these properties that we get from decentralization are very positive ones. And that's why I think it's interesting to apply them to as many problems and as many areas as possible. Like one way for me to look at it is, I think we were able to show that it does make sense to apply decentralization to finance, right? We've seen problems with the traditional finance industry, not just in the last few weeks when some of these banks had really big problems because they weren't transparent, because they weren't governed in a way that was in consensus with the majority, and yada, yada, yada. In general, the finance system as we know it is not only very inefficient because there's lots of middlemen that take a cut, but also it's not very inclusive. Now, for us in Switzerland, or for you in Switzerland, and generally for us in Europe, that's not something that we are aware of on a daily basis, right? That there are people that cannot open a bank account and thus cannot build a credit history and thus can never use credit and lever up and move in their social systems. But I digress. Like I think it's pretty clear that for finance, we've shown that decentralization is something positive. But personally, I believe similar to the internet, and I think the internet first disrupted communication, right? Like we moved from sending letters to sending emails because it was almost for free that we could send something electronically and it would arrive at the other end of the world almost immediately. And only over time, we started applying the same qualities that we get from the internet to all areas in our lives and all kinds of industries. And my belief is that the same will happen with Web3. And I believe that the internet computer is one of the key components that's going to allow us to scale into all those industries. Why? Well, let me jump to the next slide here. We talked about the internet, and Remo, I'm sure you went online in the 90s and probably sent your first emails, right? And used web services. And back then, they mostly looked text-based. And I remember sending my first email from like the command line, just because we didn't have iPhone apps that were had nice graphical user interfaces and were easy to use, not only for me, but for my parents and my parents' parents. Back then, it was all still kind of hard to use the internet. And I saw it as a huge step function once we had broadband internet. So once we went from a 56K modem that only really allowed us to send these text messages and display text on web pages, suddenly in 2004, 2005, we saw all these rich web applications come up because now YouTube and live streaming finally became possible and cheap. And I think the same needs to happen in Web3.
But I would say all of this is still super, super early stage, right? Even the last slide when you said that, decentralization disrupted finance, I would say we are not only 1% there, right? So it's super early days. And even with the internet, we're now in the year 2023. And if you travel around, you see that we don't have broadband internet everywhere yet. So we would need something like Starlink, really globally deployed, and then really have a first global broadband. And then I think we would really see the full benefit of what broadband brings. But I would say that we are much earlier than people might think.
I fully agree. I think the only reason why I use this analogy is that I think with the internet, everyone accepts that everything is like internet first nowadays, right? And that software and the internet have found their way into pretty much any industry, whether it's farming or art or anything else. That in 1995, you and me sending our emails from the command line, I think not a lot of people, or a lot of people would have been skeptical if that were to ever happen, right? I think in 1995, a lot of people were still under the impression that, yeah, this internet thing, it's great to send emails and maybe at some point we'll move our bank accounts online, but even that, we don't know if we can trust that. But to think like 5 steps ahead and see how our farming industry would mostly move online or would use the internet as a key component in how they manage their farmland, I think that would have been pretty far fetched at the time. And that's why I think that shift really happened with broadband internet when everything became a lot more accessible and a lot easier to use. It became a lot less technical. And I think that's the step that still needs to happen in the Web3 space, where nowadays, if you think of Web3, you think of wallets and secret keys or private keys managed on like some hardware wallets, and you can lose your funds, and you first need to do all this work in order to use an application, and it's just complicated. And I think that's totally fine, but I'm very excited about like getting us to the next phase where we all accept that these are great qualities, and why wouldn't we apply them to our personal blog? Why wouldn't we apply them to farming? And why wouldn't we apply them to any industry that we work in or spend time with?
So what's your personal definition of Web3?
So Web3 for me is the internet that relies on decentralized technology and that uses decentralized technology in a way that benefits the end user.
Okay, got it.
That's the way I think about it. So it could mean having a token integrated into your application or serving your website from decentralized infrastructure. That for me is like the third evolution of the web, because we gain all these properties that I mentioned, or these qualities. Yeah.
Okay, got it.
Yeah, and so just to, maybe I'll follow these slides a bit, and feel free to jump in anytime, but
Sure.
My motivation for the Internet Computer, or the way I look at the Web3 landscape at the moment, is that we have digital assets and ledgers, and that's what we really needed to show that we can disrupt traditional finance with a new type of finance. And for that, all we really needed is blockchain databases, right? Because we needed to have a shared ledger where we can say, okay, I'm moving tokens from here to there, or even we can, for those in the audience that are aware of like MySQL procedures, that for me is the analogy for smart contracts. So we can have those tokens, and we can define some rules for how they behave and how they interact with one another. But that's really it. Like, we have databases nowadays, and everything else is still Web 2. Everything, how we read from those databases and how we interact with them, is mostly guided by Web 2. And my pitch, or the reason why I believe in the Internet Computer so much, is that I think we're moving towards a future where we want to host not just the database in an open, transparent manner, but we want to host the entire stack there. And the Internet Computer, so that's the blockchain that the DFINITY Foundation has built, the tech that they've developed and then released about 2 years ago. That, for the first time, gives us not only databases, but like fully decentralized servers. And I'll talk a bit more about it in a moment. But I've already mentioned some of this. I think if something is 99% decentralized, it's still centralized, right? Because it can still be stopped. It can still be intransparent in the important pieces. And I've built here I have an example for how I think about this. So when you look at a typical Web3 application, let's say Uniswap, or I don't know, what are your favorite Web3 applications that you use often?
I don't know. I would say for me it's Bitcoin mostly, just because it's like the purest of all. Of course, it doesn't have as many applications yet, but I think it's the most important, and I still think it's the driving force behind all of this, or the proof of concept behind all of this. So and I also think that we are so early with regards to Bitcoin, and I also think that the FTX debacle was really a huge gift actually to the ecosystem, because it showed us that we really need to go back to the basics and learn everything from scratch, and learn that we cannot trust centralized exchanges and things like that. So yeah, I always try to find analogies to Bitcoin, because for me it's the most it's the thing with the most substance. And then of course Ethereum has a lot of applications, Uniswap and things like that, decentralized finance based on Ethereum. I would say these two come to mind.
So I know you've been using a bunch of DeFi on Ethereum, let's say DeFi chain or Uniswap, or all these different or yield aggregators. Yearn is there, right? Or even with Bitcoin, you still use applications to interact with your Bitcoin, right? You're probably not going into the command line and you put together a string of characters to then send your Bitcoin transaction. If you move your Bitcoin from one place to another, or if you pay someone in Bitcoin, or even if you receive some Bitcoin, you probably use some sort of an interface, either a block explorer or something like that, or a wallet, to show you that you've received a certain amount of Bitcoin. And all of these applications are hosted somewhere. So if we think about Yearn, the yield aggregation tool that's live on Ethereum, they have a front end that I use as a user, right? And I go on their website, and that's probably hosted on AWS or Google Cloud or somewhere. And then also, when I log in with my wallet, there's some code that's being executed to log me in and to show me the assets in my wallet. And that compute in the backend, that's hosted on some sort of Web2 stack at the moment, Google Cloud or Amazon again, or somewhere else. And then the assets that I see, the images and videos, I don't know if you're a fan of NFTs. I'm not a huge fan, but I hold some NFTs. And for the most part, the actual images, they're hosted on traditional infrastructure. Could be DigitalOcean, as I put here, or any of these other cloud providers that I mentioned. Authentication is another one. We rely on Web2 authentication for a lot of these parts. And if you look at this general stack of a Web3 application, it's only really the database. So a data storage that stores how many tokens you own at this current moment and gives you control over them. That's the only piece that's really decentralized in this entire stack. And why does it matter? If you look at the arrows coming from the user's web browser on the left side, they're green when they go to the front end. So by the moment that I send a request to the Yearn front end, that's the last moment when I really know what's happening. Because afterwards, this entire stack is pretty intransparent. I cannot really see what happens all the way to when it finally gets recorded in the blockchain database. And I think just yesterday, we had another example of someone. I think I saw a post online where someone lost his board yacht ape because he followed instructions that just weren't transparent enough. He didn't really understand what he was doing, and he lost his ape. In this case, you could say it was just because he was he didn't know enough, because I don't think there was any intent by someone else or an attacker to take this NFT from him. But that happens as well, right? There's phishing websites, and the use case that I always think about, I'm a big fan of like on-chain governance and creating a system where we can vote together and form an opinion together. And on the current Web3 stack, I just believe it's completely impossible to do that, because from the moment when I send my yes vote, really understanding what happens with all the steps until the result of our vote is recorded in the database, there's not a lot of transparency. And I think that's one strong reason why we need to decentralize this entire stack. And I, as a user, want to be able to have green arrows both going into the application, between all those components. I want to see what's going on, so that I can be sure by the time the request gets back to my browser and I see the result of my actions, I know it all happened the way I wanted it to happen. Because otherwise, there's not really a point in like doing something in a decentralized manner if a lot of these components are still centralized.
And would that require to basically build like a parallel internet, or can we do that on the internet? Because, for example, with the domain name system, this is usually, I think, it's mostly centralized, right? So if you want to have like domains and URLs and things, then you would like need to have a different system if you want to be fully decentralized.
So I think there are certain root servers that, yes, we cannot replicate, right? I'm actually not 100% up to date on how IPv6 works, if that also relies on like a few centralized servers, or if there's a more decentralized architecture. But everything below those TLD servers, I think we should be able to replicate with a decentralized network as well. I mean, at the end of the day, DNS servers are also just servers, right? And if we can decentralize the control over them and we can rebuild them on a transparent system, on a decentralized system, then I don't see why we wouldn't be able to decentralize the DNS system. But yes, I agree that that probably is one of the hardest pieces of the internet that we need to rebuild in a decentralized manner. But to answer your question, I think we should rebuild this with the existing infrastructure. And I don't see any harm in like going piece by piece. Because, I mean, you said it before, there's probably like 45 or 35 years of history with the current internet that we're all using, and rebuilding that, I think, would just be too big of a task. Like I think I'm always a fan of like doing one thing at a time and improving iteratively, rather than setting out this like 50-year vision and then trying to get it done within the next 10, 15 years until it sees the light of day.
Mm-hmm.
So how does this architecture, or like how does my vision for this architecture look with the internet computer? Jump to the next slide. So because the internet computer allows us to have these decentralized servers, we can rebuild all these components on decentralized infrastructure and thus make it very transparent. So the compute, the media storage, the authentication, it can all happen on decentralized servers. And that's what I think is so powerful about the internet computer. And the other thing that I find very powerful is that you see here, there still are the same logos for blockchain databases. So I don't believe in a world where we move on from Ethereum or where we move on from Bitcoin. I think there's a lot of value in having such a long chain and having so much history and having all these applications that already exist. I believe in supplementing them. I believe that we should build around them and make sure we interoperate with them in a very efficient manner. And that's something that I really like about the internet computer, is that that's very easily possible. Since you mentioned Bitcoin, I want to reference that as well. And for me, the internet computer, this is like the third generation of what's happening in Web3. It all started with Bitcoin or just coins in general. In 2009, 2010, 2011, when those first few networks went live, Bitcoin became the biggest one of them. What they really allowed us is to have these decentralized coins, these tokens, to move from one person to another. And I was fascinated when I first discovered it. I was building something in fintech in 2011. And one of my colleagues asked me to borrow my laptop over lunch to mine some Bitcoins over lunch. And I was like, sure. But at the same time, I was like, what are you doing? And it was a fascinating journey for me. The next few weekends and evenings I spent like researching how it can be possible to have scarce digital assets. Because until that point, I think the general consensus was that if we didn't trust one centralized party, every digital asset will be replicable at no cost, right? Copy and paste, and that's it. So that was very fascinating for me. And I think that generation one is really what started this revolution. And then in 2014, when I heard about Ethereum, I was blown away that now we can not only have these tokens that we can move from one place to another, but we can supplement them with scripts and we can give them their own life, and we can automate things that just previously we weren't able to automate without relying on a centralized party. And so I think there's a lot of value in that as well. And I like to research all these different chains, ETH, Near, Solana, Cardano even, and lots of others. But for me, that's kind of where they end. They're all like glorified databases. They're all token ledgers. Some of them have like multiple databases in parallel, but they're all kind of restricted by the fact that they are designed like decentralized databases, not like decentralized servers. And that's why in 2015, 2016, when I met Dom, who started the DFINITY Foundation, I was so excited about his vision for where he was going to go, because he had this concept of a canister. So he went from coin to contracts to canisters. And these canisters are decentralized servers. They can do pretty much everything that a normal server can do as well. And I've listed a few of these things here. One, no bridges, or a very technical term, threshold ECDSA signatures. We don't need to talk about the math of that, but what that means is these servers, they have a secure component where they can generate a key, and that key cannot be extracted. You can think of this as similar to how your MacBook or your phone have a component where it saves your fingerprints or your Face ID, and that cannot be extracted. It cannot be shared with another device, but it is there, and it can be used to give you access to applications and passwords and so forth. And the servers, these canisters of the internet computer, they have the same quality. So they can generate these private keys. They cannot be extracted. They're totally safe, but they can be used to interact with other chains. because the internet computer can talk to the Ethereum network and the Bitcoin network. You can now go and send a request to either send some Bitcoin or check what the current status is on a ledger item, and do that in a decentralized manner, totally safe, without relying on centralized bridges. The way cross-chain interoperability for most chain works is they rely on one or few computers that then interact with the other network, centralize that data, and move it back into this other chain. And that's one key feature that I think is really well designed and cool to interoperate with Bitcoin, Ethereum, and coexist with them. I'm just wondering, like, because you said before that you like Bitcoin, or that's like your main application. What are some of the things that you do with Bitcoin, with your Bitcoin?
I just hold it. It's like an insurance or a store of value, or just an asymmetric bet for a possible future that might unfold. That's worthwhile to me. And I also think that it's a possibility to disrupt the current financial system, just one year at a time, or one piece at a time.
As an investment, as an asset that you mostly hold, and maybe from time to time you send to someone, or you retrieve some more, or you buy some more, right?
Yeah, I think that's mostly the case right now.
And what about Ethereum? What do you do with your assets there? Do you do any yield generation? Do you do any sort of anything more active than just holding your assets?
Yeah, just a little bit. I've done some liquidity mining, or some basic DeFi applications, but mostly in a experimental way, because I've realized that these yields are mostly generated from coin inflation, and that the true proof in the pudding will be to really build applications that then millions and eventually billions of people will use, and that will then be able to generate real yield and real usage and real value. And to be honest, I haven't seen too much of that. So it's a lot of fantasy for the future, but right now most of the yields were just based on inflation. But I like to play around with it because I think it's great to have innovation. Bitcoin is like this big tanker, really slow but really stable, and it's great that we have like more vibrant ecosystems. But I'm always hoping to then integrate these innovations back into Bitcoin one day. I don't know whether that will be possible one day, because I always think about if we would want to build the world economy on a blockchain, then, and if it would have to be one, then I would choose Bitcoin personally. I wouldn't want to build the world economy, I don't know, on Cardano or on Solana or whatever, a random blockchain. I would like to build it like on the one with the most substance. So that's my thinking there. But so going back to the internet computer. So do I understand that correctly, that basically you don't try to compete with Bitcoin, with Ethereum, with other blockchains, but you try to decentralize components of the internet that haven't been decentralized yet, and basically build those infrastructure blocks to supplement the whole Web3 or the whole decentralized ecosystem. Do I understand that correctly?
Yeah, I mean, maybe the one thing that I would push back on is, like, we don't try, because it's already here. It's already running for 2 years.
Okay.
And it's not so much about just those components, because you can have native tokens on the internet computer as well, right? And I think down the road, I'm a big believer in, you want to build everything in one place, ultimately. As a developer, it's just easier, it's cleaner to have everything in one stack. I mean, the reason why, if you build an application, you don't put one server on AWS and the next one on DigitalOcean and the third one on Google Cloud, is because it just creates lots of issues and potential safety and security risks if you decentralize your infrastructure too much. But of course, it's possible. And that's why I think, because you said before, ultimately, I would love to, I don't know if it will ever be possible to build those kind of yield aggregators and other applications on top of Bitcoin. The cool thing is it is possible now because you can natively interact with the internet computer, with Bitcoin from the internet computer. So you can create and hold your key on the internet computer in a canister in one of those servers, and from there control your Bitcoins, at the same time control your ETH and several other chains. And I think it already creates this like consolidation and a way for you to safely and securely manage all your different assets in one place that I find very fascinating. But of course, yes, there's more stuff that needs to be built. And I think DNS is something that is on this roadmap. It's like, how do we recreate the DNS system in a decentralized manner? But maybe before diverging too much, just a couple more things I wanted to mention from this slide is, because you mentioned DeFi applications before, and very often it's quite odd how, for example, Liquidity, which is a lending borrowing protocol and stablecoin on the IC, and in order to understand how well collateralized a user is, they rely on oracles. They need to understand what the price of Ethereum is at any given point in time. And there's big companies that were built around this problem. One of them is Chainlink. Basically, what Chainlink does is they have a bunch of, they have a network of people and servers that ping different price exchanges, collect those values, and then send it or write it to a chain where smart contracts can pick it up again. And it's costly, and it doesn't scale really well, and it's also pretty intransparent because you don't know if this network suddenly starts to go rogue because they started to understand who else is contributing these prices, and they might have an interest in maliciously changing the prices that they're reporting, yada, 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 right? But it's a system that works, but for me, it's always been kind of a hack. The cool thing about the internet computer is because these canisters are like servers, it can natively talk to these exchange servers, it can talk to CoinMarketCap, and it can just get the price of Ethereum at any given point in time in a very secure manner. So that's one thing that I find very cool. And then on the other side, because they are servers, they can also serve web browsers directly. So maybe later on, we spend a bit of time and go to like different applications that were built on the internet computer. And one of them, for example, is OpenChat or Discover, and we can bring them up later. But the way I access them is just by the browser. And my browser directly goes to the URL that's served by this canister. And that's something that I find really, really cool. I don't rely on yet another infrastructure provider that could potentially phish me. Mm-hmm. And then a couple, sorry. The second row is probably more conceptual changes. So one is that we believe, or the DFINITY Foundation believes, that in order to bring the next million and billion people onto the blockchain, it's important to not create too many hurdles up front. So if you want to use Bitcoin, first you have to get a wallet. If you want to interact with some sort of DeFi application, first you have to get a wallet, and then you have to get tokens before you can really do anything. With the internet computer, it works a bit differently, where it's the developers that prepay their servers so that the applications can be used. And they're able to do that because it's a lot cheaper. So storing a gigabyte of data is about $5 a year at the moment. And that's a constant rate. So it doesn't depend on whether ICP is at $5 or $20 or $100. That's always the same US dollar amount. So that's something that's very easy, sometimes almost too easy, because we have some applications that are used by like thousands of people every day, and they probably don't even understand that they're interacting with something that runs on the internet computer. Second, the horizontal scaling. So there's no subnet, and subnet is kind of the name for a parallel chain, or like a shard would be the term that's used in other ecosystems. A subnet is like a data center, and the data center, they all operate on the same hierarchy, and not one subnet is more important than another. And that's great because it means you can scale much better than if you relied on like going through one of these subnets every time you want to communicate from this data center to this data center. And then the last one, assets on chain, or what I wanted to put there, but I see this is not updated yet, is on-chain governance. It's great that the internet computer, every update that the network goes through is controlled on-chain. So there's proposals that are being submitted then everyone who has ICP staked is able to vote on them. And then afterwards, that automatically gets implemented if it's a yes vote after the voting time runs out. So yeah, but those were just a few slides that I wanted to show kind of as an intro. Feel free to close them now, and then we can dive a bit deeper into any of those areas that you or anyone in the audience find interesting.
Yeah, absolutely. So what applications have been built so far, and or can you show us some cool applications so that we can get a feel for how to use it?
Yes. So let me try if I can screen share from here. Just 1 second.
Yep.
Okay, so I started sharing. Maybe you need to do something in order to actually show my window.
Yeah, I'm showing it right now.
Okay, so can you still hear me?
Yes, I can.
Okay, so it seems like my streaming window, other browser should now show a web page that's called theinternetcomputer.org, and it should show this World Computer.
Yeah, you're cutting off a little bit.
It started with the sharing, so let me stop the sharing for a second. Is this better now? Can you
I
hear
always,
me?
Yes, I think now it's better. I always do a second browser window, or maybe a second browser so that it's not like interacting. Maybe that could solve it.
That's what I did. Let me try a second browser. I used another Chrome window. Maybe that's the issue. Let me know. You immediately start moving a bit more slowly once I start sharing.
I think now it's okay. We can try.
So one that I always like to show at the beginning is this page that's called theinternetcomputer.org. This is one of the key resources if you want to learn more about the Internet Computer or ICP. And this website is directly served from the blockchain. So the only thing it does rely on is the domain name system, the DNS system that it still relies on. But other than that, everything that you see here, all the JavaScript, all the images that you see coming up here, they're all served directly from decentralized infrastructure. And you see that it allows for like nice animations and colorful websites, like what we imagine a good UI and UX to be like. And if we jump here, we can now look at some of those applications that are live. And I always like to start with Discover. And that seems to be loading, so it should all be good. Yeah, so Discover is a social network or a social media app that's kind of similar to Reddit. So Reddit, the discussion forum, that one relies on subreddits. Here we have so-called portals. And if we scroll here, we'll see that we can open one of these. I haven't looked at what this is, but we see there's an image that's being served and there's a bunch of text. And if we scroll all the way down, we also see that there's comments and there's upvotes. And if this worked in my other browser where I'm logged in, I could also leave a comment, or I could also tip people. And this is where the Web3 aspect comes in, right? Like, not only is this censorship resistant and the content that I post here truly belongs to my account and not some like centralized party like Meta, but I can also, since this is all Web3 enabled, I can tip people for their comment or for their post in Web3 tokens. So I could send an NFT as a thank you, or some sort of like a mini fraction, like 0.1 cents of like a stable coin, if I really like what this person here has posted. And I didn't read this, so hopefully it was not something embarrassing. But that's kind of a really cool example of decentralized social media that's up and running. It's used by about 10,000 people each day, growing by the day. And just yeah, for me, a great example for how they rethink social media and how they rethink revenue streams and censorship and moderation and all along that.
So so do you see it realistic, for example, if we now compare this site with the original Reddit? Of course, the original Reddit is huge, has huge network effects, a lot of users, a good brand, people love it. So what or do you see a future where Reddit might migrate to the internet computer? And if so, what benefits would Reddit have, and maybe what disadvantages would the company have if they wanted to migrate?
Yeah. Well, that's an interesting one, right? Because I think historically we've seen only very few companies successfully shift to a business model that at first cannibalizes what they are doing. And I think the general consensus in social media is that we do not like to have our data exploited. Pretty much the dominant business model for all these social networking platforms that we use today, including the ones that we're streaming on today, is advertising and exploiting my data so that I can be sold some products and services from third parties. And I think the exciting part about reinventing, not just transferring, but reinventing social media in Web3 is to get rid of that and find new business models. And the one that I mentioned before, microtransactions, what if people like to like each other's content so much that, and like want to pay these microtransactions and share content and monetize content within the platform? What if we just took a cut of all those streams? So if I send you 0.1 cent, what if someone took 10% of that in the middle? Would that eventually become a business model that's more exciting than advertising, right? I think that is what it comes down to. Are we going to see some of these new social media companies find a way that allows them to grow quicker, faster, and become bigger, at least in certain metrics, than the incumbents? I think only at that point, the incumbents will start looking at, oh, is this something that we should jump on? Because before that, I think it's just too hard to give up your existing business model. And if that at the core isn't in the spirit of decentralization, then I think it doesn't really make sense for a Reddit to move over to the internet computer. Even though like capacity-wise and performance-wise, we're probably not there, but also I think there is a pretty clear way how we're going to get there within the next 2 to 3 years.
Got it. Are there applications that you are excited about that are completely new and not like a competition for existing services? And if so, could you show us some? Or just some other applications that you find personally useful?
Yeah. I mean, both. I was just thinking of where to start. So I think so. Plethora. And let's see if this loads. This might be again because I'm not using my usual browser. But so this is a game that uses Web3 at its core, where and I'm sure you know about this, like where you can really own the collectibles, you really own the characters, and you can potentially move them to other games as well, to different worlds. You can also incorporate NFTs that you already have into your game. So that's something that I find pretty cool. Let's see if I can. So here we have like 2 players that are currently betting on something. I haven't used this in a while. Now see, I'd have to log in, and I don't have my wallet in this. But one thing I wanted to point out is like that with Discover and here, I can at least like read and do certain things before I have to log in. That's why I think it's cool that we have, even though this uses computation and storage that someone has to pay for, here it's not me. Like I don't have to first get a wallet before I can do anything. I can read Discover all day. It's only when I really want to interact that I need to have a profile and thus log in. So I think in gaming, even though I'm not a gaming specialist, by the way, do you play games? I don't remember if you like playing games and if that's something.
Yeah, a little bit. I like playing Fortnite with some friends.
Okay, so I don't spend a ton of time gaming. It's actually something that I do want to get back into because I think it'd be a nice balance every now and then. but I haven't played games in a while, so I'm probably also not 100% up to date. But I think that's where a lot of new ideas start to exist, and there's a lot of like evolution on existing concepts. Another one that I quickly wanted to show is OpenChat, and OpenChat is a decentralized version of Telegram.
Mm-hmm.
Well, let me see if I can just create a test anchor here and create a wallet. So by the way, what we're seeing here is the identity system that comes with the internet computer. The way it works is by using, so you don't see it, but like it asked me to like put my finger on the fingerprint sensor of my computer. And that's what it uses as the element to, now if I wanted to add a recovery method, it would ask me to, we can actually look at this. So this is called internet identity, this wallet that's kind of built into the internet computer. And you see here that I could now go ahead. So my first login method is just to use the biometric device in my laptop or my phone, which I think is great, right? Because that's a lot more.
It's a lot more intuitive. Yeah, it's easier.
A lot more intuitive than using like the seed phrase from the start. Plus, just by displaying the seed phrase in my browser, I mean, I'm going to do it now because this is a throwaway account, but someone that's like seeing this can now take over. They could copy what I have, and I just like to operate under the assumption that nothing is safe that happens on my laptop, even though I try to take really good care. But it just isn't safe if it's ever been on a connected computer. And so most of the existing systems, I just have a very hard time like trusting their security with a lot of my assets and my identity. So even though I can use this here as a recovery method, I can also go back, well, or maybe I have to quickly click on it again. But by design, the way I set up my internet identity is I log in from a few different devices where I have the biometric sensor, and then I use a YubiKey or like a ledger device as my secure element as well to log in on a new machine that I haven't used before. And that is just inherently so much safer and also more usable and just better usability than having to keep track of this seed phrase.
Absolutely. I think the seed phrase is one of the hurdles for Bitcoin and Ethereum adoption.
Yeah,
definitely.
Okay, so let me see, this is probably available. Yeah, now I need to complete. So now this is on the OpenChat site where it's allowing me to create so I created this new identity for internet identity, the identity system for internet computer. And now I've used that to log into OpenChat. And since it's my first time logging into OpenChat with this account, it asked me to set the username, kind of the same way how if I use a new SIM and I download WhatsApp, it asks me like, what do I want my status to be or my profile picture to be like. Oh, I guess I did not get the capture right. This time it looks right to me. And do you, maybe while this loads, how do you think about like Telegram and WhatsApp, and would you see a value in a decentralized alternative?
Yes, absolutely. I think that's an application I would see really good value in, especially because people are already used to like having 12 different messaging apps and channels. So I think this is not a winner-take-all market, and I think while network effects are strong with each one, I think a new entrant could easily, take significant market share. So I would see that as a good application actually.
Yeah, and the reason why I think it'd be cool to decentralize that is because there's a huge amount of data, and this has happened over and over again in the past, right? We basically have to trust the Facebooks of this world that they really treat this data securely, that they don't share it with anyone. And if you remember the early days of WhatsApp, like everything was basically out in the open. Anyone that sniffed the network could see the messages in plain text. And that's something that to this day, I can't really verify if Facebook does anything with my data and what they do with it. And having this rebuilt on a stack that allows me to fully verify that no one has access to my data unless I let them pay for it or whatever the use case may be. And that if I set a message to disappear after, let's say, 24 hours, it actually disappears and there's no copy of it stored. That'd be something that I think would be great to have. So so now we've logged in, and I can do one of two things. I can message one-on-one or in groups that I create, or I can create these communities or groups that already exist. Now, in this case here, you see there's a group of over 25,000 members. I'm actually not sure if it's still syncing or if I just don't see history that was before I joined. So I'll keep this open for a second, and then maybe let me see if I can find someone. If I remember the handles of someone that I've messaged in the past, so we could show a bit of a demo. Quickly gonna look over in my other browser. Yes. This person is not online. I can't. So it's pretty clever in the sense that it, let's try this, if I can open this URL. It's pretty clever in the sense that it, okay, so yes, so here I am in a code and state group. Mm-hmm. And we'll talk a bit more about what code and state actually is a bit later. Absolutely. As well, but I'll go join this group, and then I can actually message these people. Okay, so now let me say chat. Hey Seb, this is Cédric from a test account giving a demo on a live stream. Let's see if he replies. But you see that mm-hmm. What I can do down here is I can similar to what I can do on Telegram, I can send files, I can send emojis and stickers, I can send voice messages, but then I can also send tokens, NFTs or fungible tokens. There's not a ton of them that are integrated right now, but there's the open chat token, which is called chat. There's Internet Computer, ICP, the main token. Mm-hmm. And very interesting for you, there is CKBTC. And CKBTC is basically is Bitcoin that I access through the Internet Computer. So I could then create a wallet. If I go here, let's see. Interesting. Okay, so I actually need to upgrade my account for that. That I didn't know. That seems to be something that they recently introduced. But with ICP, I could now take this address or this QR code, send some ICP here, and then I have it in my OpenChat wallet. And at that point, I can start sending tiny fractions of Bitcoin or ICP to some of these people. And it's great. It's a great use case for like a friends chat, if we want to split the bill or if we want to build something together, to just send those tokens or NFTs. Right now, what usually happens is I would go here and I would ask Seb, hey, what is your address? And then from my wallet, I would send him some ETH, and then I would ask again, like, did you receive it? Here, I could just have it within the conversation.
So who is running these canisters or servers these days? Yeah. So are these the developers that are building these applications, or are these regular people like you? So do you have a canister or a node? If so, what is the benefit?
You're calling me a regular person, Remo. You should know better.
Yeah, absolutely. So who's running it? And yeah,
yes,
give us a sense of how the infrastructure is built.
And how decentralized is it, right? Because
how decentralized is it? And maybe how many servers are there? Is there a number just to get a little bit of feeling of how the network actually looks like?
Yeah, so I don't know the exact number. That's why I pulled up this page, dashboard.internetcomputer.org, which is where the network reports all of this data. And the people that run nodes, or the entities that run nodes, are called node providers. And if we look here, there's currently 77 different parties that run nodes, and they run anywhere from, this one seems to be a test, but there's one here that only runs a single node. So that exists all the way up to 9 Yards Capital here, which runs 49 nodes. So there's a pretty broad bandwidth, and if we just go to nodes itself, we can see how many nodes there are and where in the world they currently live. So there's 549 nodes that are live. I know there are more. Yeah, we can see here 904 nodes that exist, and I think it's the 549 that are currently live in one of those subnets, so the ones that are doing the work. And that's just purely because we haven't reached capacity limits, so some of these are running idle at the moment. But you see that there's roughly 1,000 in total that are run by those 77 different parties that are currently live. Now, is this the end game? Do we not need more decentralization than 77 parties? No, but I also think 77 parties is a good start. That's reasonably decentralized, because it would probably be hard for someone in those 77 to go out and meet all of those other 76 node providers and collude with them in some sort of way.
And how difficult is it to run a node, or how expensive? Can you?
Yeah. So there's two different types of nodes. The ones that we looked at here are the full nodes, and these are pretty expensive. They cost you, I want to say, about $20,000 to buy. So it's comparable to like early Ethereum days when you had to buy your FPGA and you bought 5 of them, and they each cost like 100 grand, or I don't know what the exact number is, but like somewhere in this ballpark. And it will certainly come down as we increase the number of node providers, right? Because it can be mass produced. But it's pretty expensive hardware for these full nodes. There's also something called a boundary node. And the boundary node is a very simple machine that you could also run in your basement. And a boundary node is basically just data storage. So they just copy the data that runs on the full nodes and make it accessible more easily and cheaply. And I don't know exactly what the cost is for one of those, but I imagine like a few $100s, similar to like a normal PC. The thing with full nodes, because in order to like make applications as performant as this and allow all of this information to be stored, including images and all the JavaScript and everything, we need an environment that's kind of similar to a Web2 environment. So you are encouraged to run your nodes for the internet computer inside a data center. So, and yes, I am one of those like normal people that run a DFINITY node or an internet computer node, and I do it in various data centers in Switzerland at the moment. So there's a cost associated with that as well. And because you are paid, we spoke about this earlier when I said the cost of like 1 gigabyte of storage per year is roughly $5. And I said dollars, not ICP. It's because on the backside, it's also, that's how you're paid in terms of your dollar cost. So for me to run my nodes in these data centers in Zurich, it costs me a certain amount of Swiss francs per month, which I can translate into dollars. And that's how the network pays me. They give me a fixed return of a few X on my monthly cost and the amortization of my machine over a few years. And that's how I'm incentivized to keep them running and to potentially even buy more hardware and become a more proficient node provider.
Got it. So it's profitable to run nodes. So you also get revenue, or you get some some fees for the usage of.
Like a simple calculation could be, let's say you pay 20 grand for the machine itself, and you're paid over 4 years, so that's $5,000 a year, and then maybe it also costs you $200 a month. So over the year, that's another $2,500. So if that were the numbers per node, $7,500 that it costs you to run this machine for the next 4 years, then I think I don't have the current numbers off the top of my head, but then you get like a 2.5x return on that. So you would be paid 20 grand each year in ICP from the network. At the current conversion rate of ICP to US dollar to provide as a node provider.
Got it. Okay. And the people that basically use the build applications on it and use storage and use some resources, they pay these fees.
Right now, there's a difference, just because there's a cold start problem, right? You have to have certain node providers that already are up and running before you can start building applications. Sure. So the network paid a bit in advance before the gas fees came in. And also you see that not all of these nodes are at max capacity, because just roughly 2/3 of them are currently being in active use. So right now there's a bit of inflation because the network pays these node providers while there's not enough gas fees to cover all of that. But yes, that's the vision, that like the more activity comes to the network, it's basically a shift from the gas fees that are being paid by developers, which of course in turn might charge their users. Like you saw that OpenChat tried to charge me with like a diamond account. So it's the developers that buy storage and compute, and in return that money is distributed to the node providers.
Got it. So you are now mostly getting your fees or your returns from the network inflation. Is that correct? Or
the returns that I'm getting, which is a fixed proportion, is created by the network, and that is slightly inflationary.
Yeah, got it.
It's not a huge factor.
Yeah.
You can probably find it somewhere here, even, but like compared to the staking rewards, which are also inflationary, right? Like for people to stake their ICP and participate in governance, they receive staking rewards. I think that's like 50x or 100x comparatively.
Got it.
To the node provider rewards that are being created.
So you talked about the stack. So is the stack completed, or what elements are still missing for it to be like fully built out, or what is the roadmap?
Yeah, I'm sure it's somewhere here. Let's see. So maybe let me just Google it. I mean, the high-level answer before we bring up the roadmap, the high-level answer is it works. There are, as you saw, like Discover runs fully on chain with 10,000 users. But of course, there's always things that can be better. So for example, the Bitcoin integration is live, can be used by anyone, but then the Ethereum integration is just going live. So that's something that the team has worked on. And then of course, after that, we want to integrate with other chains as well, so that this truly becomes the one chain that allows you to safely interact with every other. Then there's always, I said before, I think this is of course thousands of times more performant than most other chains, but still, like in order to compete with Web2, that's quite a task, right? To do it in an open, transparent infrastructure or architecture. So there's always like things that need to be built, but there's not this one thing that I talked about that's not live. All of what I've mentioned is live and is usable, but of course it can always be better, more user-friendly, easier to interact with, and so forth.
Got it. Yeah. So could you maybe talk, because your work is now mainly focused on the internet computer. So could you talk about your own companies and projects and your focus, what you are doing?
Of course. Let me unshare this and we'll jump back into I'll jump back over here to Restream. So maybe for this, I'll just jump onto a slide as well, just with a bit of background on myself. Here we go. So this is the Code and, or part of the Code and State team. We've grown a bit since then, and I'll talk about what Code and State does in a bit as well. But about myself, like what really gets me excited, and I think this is something that we share, is that what gets me out of bed in the morning is to find ways to use all these cool technologies and decentralization and this tool set that it gives me to have an actual impact on my life and hopefully the lives of millions of other people. That's right, what really drives me and has been driving me over the past 20 years. And while I've done lots of things outside the internet computer ecosystem, I've also done quite a few things inside of it. So I helped start the foundation now roughly 7 years ago in 2016. And I've actively built it out in an operational role until early 2019. And at that point, I took a step back from the foundation and I started Tomahawk.vc, which is a venture fund where I've invested in other ecosystems, but also the internet computer ecosystem. And I have like 5 or 6 portfolio companies that I'm actively helping get to the next step, raise funding, and develop on the internet computer. Then we talked about it before. I'm a node provider in the IC ecosystem as well. That's a business. And then last summer, I decided to start Code and State. And Code and State is a venture studio. And I'll skip forward a bit. We saw some of these slides already. And this is where we stopped. It's pretty cool what the internet computer does, or at least I think it's pretty impressive what we can do. But it's also not to say that, of course, it's still hard to build on the internet computer. And there's lots of challenges. I mean, the reason that you've never heard about the internet computer is not because you live in a hermit shell, right? It's because it's hard to tell this message and tell this story and get people to understand how this works and how the paradigms are slightly different. And there's lots of other things as well, like for developers and builders on the IC, there's a new language to learn, or you can use Rust or Motoko. Motoko is kind of like JavaScript, but it's slightly different. And you got to understand how to interact with these canisters, these decentralized servers. You got to deal with like token standards that are not as established as Ethereum, which is now 9 years old, right? So it's natural, like things are just emerging, and that just means things are slightly harder than if you go to Web 2 or some of these like Web3 database chains. And Code and State focuses exactly on that problem, that it's hard to start on the IC at the moment. And we're doing so by building lots of things, some in tandem with the DFINITY Foundation and lots of other things independently. And the goal that I'm pursuing with the internet computer, or with Code and State, sorry, is to make it so easy that a builder can start on Saturday morning, and by Sunday evening, they not only have their app live, but they've already earned their first dollar. Because I think once we get there, then everyone will start to experiment and decentralize their own personal blog, and they will decentralize farming, and they will decentralize healthcare, and so forth. And lots of these experiments will not be successful, and that doesn't matter, because if it's so easy that you can just spin up a new idea in a weekend, then we'll see thousands of these experiments, and at the end, one of them or 10 and hundreds of them will be successful billion-dollar businesses. So that's what really drives me, is like making it so accessible for builders that they can get started within a weekend and get some feedback and kind of get to a point where they can see how this could turn into a business, or at least could get them really clear product market feedback. And how do we do that at Code and State? We do it by accelerating and incubating ventures. So Code and State is a group of people that is pretty dynamic, and our goal is to help an individual or a team to get started. And for that, we provide funding for the first 12 to 24 months. So it's kind of an alternative to pre-seed funding. There's a founder that thinks, it'd be kind of cool to build like Firebase on the IC. Firebase is a Google concept. It's like a kind of a no-server cloud where you focus, something that's great for front-end developers, so developer tooling. If someone wants to build that, and someone actually is, that's why I came up with the example. If someone wants to build this but doesn't really know where to start, they're probably a great developer, and maybe they've already led teams, but they've never been an entrepreneur before. Now, they could go out and raise $1 million, and then they'd have to deal with everything that comes with that, right? They have to learn how to hire people, educate them, especially in a new ecosystem. They have to build a relationship with the foundation. They have to figure out the legal and tax stuff, which unfortunately for Web3 is still pretty hard and complicated, and yada, yada, yada. Or they can come to Code and State and say, hey, I think I'm aligned with what you guys are doing, because if I build this Firebase, then it will be easier for people to get started within a weekend and earn their first dollar. And we'd say, yes, perfect, come join us. We'll pay your salary, we'll pay your runway, we'll help you hire your team, we'll set up your company for you, so you can focus on your product and your tech for the next 12 to 24 months. And at that point, you still own 80% of the business. So we take 20% as a venture studio, so minority share, and then we'll let you go out into the world and raise your own funding, and we'll help you with that. The idea is that we create a launchpad, an environment where it's very easy and exciting for you to work on your idea for the first 2 years, and then you go and leave and take your business to the next step.
Got it. So the goal is to basically, to create new applications and really, apps that become popular and that people use. And it actually, I think, for the user, does it matter for the user that it's built on the internet computer? I think it does, because you need to have the basic authentication, right? But in the end, I don't think it matters that much, right? So it's more about the applications and not about what it's actually built on.
Yes, I mean, that's my vision, right? Because I think in Web3 right now, we're very technical. We ask like, oh, are you an ETH developer or are you a Solana developer? We talk about like how safe Bitcoin is versus how safe Ethereum is and that kind of stuff. But I think ultimately it'd be much better if we just thought about like, oh, is this decentralized? Yes. Oh, so then it enables me to use my tokens in a good way, or it allows me to completely own my data that I'm creating within this. Because I think those are the more like user-centric stories than the, okay, is this built with a chain that has X amount of transactions per second, or yada, yada, yada. You see what I'm getting at, right? Like, so at the end of the day, if someone logs into Discover, they shouldn't feel like they're logging into the internet computer. They should feel like they're logging into an application that is fair, that is that adheres to Web3 standards. Mm-hmm. And they don't really care if it runs on the internet computer or somewhere else, because it's so fluent, and they're not required to like create like a certain identity or something like that. So that's my vision, is like it should just be hidden away, like the same way we don't think about like, is Restream, the software that we're currently using to stream this, does this use Amazon Cloud or Google Cloud in the background? It just doesn't matter to us. We know it works and it's fast.
Yeah, so you're basically providing, or you're just building on an infrastructure based on a specific set of philosophies and values and parameters, which happens to be Web3 or happens to be decentralized. And then you basically build companies on top of that. And by users using those apps and companies, they will then automatically also use the decentralized aspects, right? So you basically onboard through the apps that you help build. You basically onboard the users to a more decentralized web.
Very well said. Yeah, that's exactly my vision. Yeah.
And we also have some comments here. So Stefan says, very interesting. And here Exec Z says, damn, this kind of incubator has to be connected with the universities. So are you thinking, how are you reaching your potential entrepreneurs and founders? And are you also working with universities?
We're actually, so one of the initiatives that we're building within the internet, within Code and State at the moment is, it's the one in the top left. It's called the Motoko Bootcamp. And the bootcamp is a 7-day course where anyone and everyone can get started with the internet computer and building on top of it. And we run it both online. And if anyone listening to this wants to sign up, if you just, either you can send me a DM or you can go to motokobootcamp.com and sign up there, apply. We're running an online version where we already have over 1,000 signups for the next one in May, but then we're also running an in-person one. And the next one in May, we're doing together with the Florida International University in Miami. So it's going to be a 7-day program where you can come to, and you have to pay for your own accommodations. We're not sponsoring everyone, but we're also not charging anything for the educational part of it. And then you come to a co-working space, and for 7 days, you get to learn about the internet computer and solve challenges with other students that are at the same place. And it's a great way to get to know co-founders and mingle with others that are also excited about what's happening in the decentralized world. So that's happening May 8th to the 14th. in Miami, Florida, or online for those that want to participate online. And then the other initiative that I want to mention here quickly is the ICP Community Conference. ICP-cc.com is the website, and that's going to happen. And I think I have an extra slide for this. So this is the bootcamp. This is also going to be in Miami just a few days after bootcamp, where we bring together the entire ecosystem. So we bring together the builders, the investors, and people from other chains that just want to learn how to deploy their front end on the internet computer. We bring them together in this very cool looking building just outside Miami for a 2-day conference where you can learn everything about the IC and connect with everyone in the space.
Cool. And then we also have a question, a little bit a technical one. I don't know whether we want to get into that. Ingmar asks, computing power provided by, for example, AWS is also bound to the many services modeled on top of AWS service catalog, for example, IAM, network, firewall, load balancing, etc. Securing your environment and designing your architecture as from code on these platforms. You don't. I don't think you see the whole question.
I see the question on the left.
You see the question on the left. Perfect.
Securing your environment and designing your architecture as from code on those platforms. How will ICP reach this state? So if I understand correctly, the question is, how are we going to get to a place where these components kind of interoperate in a very secure and safe way if someone goes and builds the equivalent? And by the way, feel free to stop the screen sharing if
Sure.
we're going through questions. How are we going to get to this state? And I think we're going much faster than we did in the Web 2 world, because in the Web 2 world, we basically rely on centralized parties like AWS to build all of these. Whereas in the internet computer world, someone might choose to build a service for authentication, and that already exists. And then someone else might build like a really cool NoSQL database on the IC. And then those two, by design, are interoperable because the standards and the interfaces are open from the start. And that's why I think decentralization into Web3 is so cool, because we're going to be so much faster than we were the first time around, where everyone was kind of building in their own garden with their own standards, and security by obfuscation was kind of a thing. In Web3, everything by design is open and accessible. And that's why I'm very excited about moving this entire movement forward.
Cool. Yeah, let me just talk about scaling, or I just had the question pop into my head. What if one company just blows up and becomes really huge, like Reddit size or whatever? How would the network then scale? So in the early days of Twitter, for example, the Twitter whale was dominant. I'm sure you remember. So the servers couldn't keep up with the growth. So how would something like that work if one of those companies really blew up and became huge?
Yeah, I mean, and by the way, I think even in most recent days, Twitter has had some outages. So I think it's something that seems to be pretty close to their DNA. Is that anyway? So of course, not all the cookbooks or all the recipes are in the cookbook, but the cookbook in general exists. These subnets, which I used the analogy of data centers before, are groups of a few dozens of these nodes. And the more nodes we have, the more of these subnets can exist, and applications can just scale from one subnet to the next. And that can even happen behind the scenes, not in a way where in Web 2, as a developer, I remember like before AWS, you had to write all of this manually, right? And like spin up new instances on the go. Well, all the way back, you had to go into your server room and like plug in an additional machine, get it up and running, configure it. And over time, you could automate more and more of this. And the idea with the internet computer is that it's completely elastic, so that if there's more requests, if the latency drops below a certain limit, then it just auto scales your application. And the same way, if your latency is just extremely low, then resources are reallocated to other applications that need it more than yours at the moment.
And yeah, how would then other people be incentivized to bring up like more server capacity? So what if like one application used up all of the capacity and then it still wouldn't be enough?
I mean, by the same way that they're now, it's a great investment and it's great to participate. Also, of course, if you run a full node, I mean, I always question how many people actually do this, but there's some maxis that think you have to run your own node to really read the network and see all the data that happens in the network. So that might be an incentive as well. But in general, it's just the network incentivizes to, right? If the developers are willing to pay gas fees and those get distributed to the node providers, then that can be pretty lucrative if we are in a phase where there is such demand for more compute and storage.
Cool. And yeah, you said that the network currently is providing a 2.5x return or something like that on your investment.
So don't quote me on this. Let me screen share again and just quickly bring it up, because I also saw that a question.
Yeah, and it would be, yeah, exactly. It would be just interesting to hear from you how the inflation will continue or how long this incentive will continue. So would this still be like a worthwhile mini venture for some people to provide additional nodes?
Yes. So, and maybe one thing, I mean, I can speak for the foundation and I can speak for the network, because all of these decisions are made by the network. Yeah, you should be able to bring my screen up. Let me know when you see it.
Yep.
Okay. So what I did is I just Googled how to run a node on the internet computer, and then there's a support page that comes up on the DFINITY.org site, and I'm sure this has a bunch of this information, but it's not the one that I was looking for. Let me look here.
And we also have a follow-up question by XXZ who asks what hardware would be required to run a node. So maybe we can.
So I think I'm on the perfect page for this now. So so this actually outlines how you purchase the hardware, what kind of hardware you need. So I clicked on this first link. There's like generation 1, generation 2. Yeah, so this is the hardware here. Here you can find the specs that you need to create. There's also discussion going on for the next generation. So this is the forum. There's lots of like very interesting insights here. So I'm just trying to pinpoint any of our listeners to the right place so they can go look this up afterwards. But then this here, so up here we see the hardware that's required, and then down here we see how you go about like submitting a proposal to the network for the network then to accept you as a new node provider, so that you become registered and go live. As I said, this is a fully decentralized process. Everyone that has ICP staked will be able to vote on these proposals and thus have an influence over it. And I'm sure somewhere between those two pages that I had opened, this one and the other one here, I think we would also find out about the remuneration. How much am I paid to? By the way, I'm still using Google and not using ChatGPT for everything, which how much am I paid to operate a node for internet? Let's see.
Yeah, the problem with ChatGPT is that it only uses data up until 2021, I think. So it's quite old, right?
It actually knows quite a bit about the internet computer. It can even write stuff in Motoko. So the other day I said something like, "Can you write a simple backend application about that does this and that in Motoko?" And it can do it. So I think the cutoff point is kind of like a sticker that they've put on, but I think under the hood it has access to a lot more. But that's probably enough for another 3-hour live stream. So before we go down that rabbit hole, I would just suggest to Google it. I'm sure in this thread here somewhere we can find out how much it is right now. And there's probably also some good page online. Also, if anyone from the internet computer community is watching and has seen this question or knows where to find it, feel free to leave it in the comments so I can share it while we still chat here. But yeah, long story short.
Or how did it work for you? Could you walk us through how you set up your node and what steps you had to go through to get accepted by the network and just the milestones?
Yeah. So those steps are basically the ones here, because I did it before the network went live, I had some help from like an engineer on the DFINITY team. But nowadays I wouldn't need that, but because I started like a month before, let me see if here, this is the page that I wanted. So it basically is all these steps that you find here, and it looks like a lot, but that's also because there's a lot of screenshots. But this all outlines how to do it, and of course there also are people at the foundation that be really happy to jump on a call and walk you or someone else that's interested through this process, or do a live stream about it and walk someone through, because it is a technically involved process, but it's not something that couldn't be done. Like I have a technical background, but I haven't really written production code in 10 years. And it's something that I'm able to follow and go through.
And then how much work is it to maintain a node? What do you need to do now while running a node?
Yeah, as long as it's connected to the internet and as long as it has power, nothing. At the beginning, I define where I want to receive my rewards. So the ICP that I get on a monthly basis, and then so I actually get them on a bi-weekly basis. Every 2 weeks, I receive a payout that's based on the price of ICP. As I explained before, like if the price of ICP goes up in dollar values, then my absolute number of ICP goes down, and vice versa. But that's about it. There's nothing I need to do on a daily basis to keep the service running.
Cool. So, but you, of course, there are software updates and things that you would need to do, right?
No, this is all done by the network. That's the cool thing,
okay.
With Ethereum, I'm sure you remember the hard fork after the DAO, right? Where people came together and some people thought, oh, we should revert this transaction. And then other people said, no, this should remain as is. And the way this worked for the Ethereum communities, they discussed on some forum something similar to like what we have here. And then at the end, I don't know if they if they ran a poll or if they just said, okay, now everyone who thinks it's good to revert this like updates their machines to X, Y, and Z. That's not how things happen on the internet computer. On the internet computer, we have, it's called the NNS app. Also, this application runs 100% on-chain. And let me see if I can log in with this identity that we just created before. Yes, this should work. So now it asked me to put my fingerprint, my finger on the fingerprint sensor again. Now it's finalizing the authentication. So now we logged in. And if I did this with my real identity, I would have some ICP here, and I could see my CK Bitcoin tokens and so forth. And what I could then do is go over here to staking, and I could say, I want to create a neuron. A neuron basically is a pot of staked ICP. So I would then say, let's stake 5 ICP. And with those 5 ICP being staked, I then get voting power. So now I can participate in the governance of the internet computer. And that's the third tab here. So I see there's a vote on proposals here. And we can go look at one of those. That's currently open, and you see this is brand new. There's only been 144,000. So this is weighted votes, as probably only very few people of the network. I think the total network has probably 50 million or 100 million voting power. But long story short, so in here, this is an NNS canister upgrade. So canister that runs this NNS app here. So this app here is being upgraded. And the summary here is it wants to update this ledger to a certain GitHub commit that I could now go and verify. And this is how I could verify it. Here's some rationale behind it, the changelog. And then this is the payload. And if this proposal is accepted, so if it ends up adopting, more people voting to adopt than to reject, then it's automatically executed. This code at the end here, this payload is executed, and the code of the NNS app, which I'm using to vote on this, is upgraded. And that's how every single change on the IC happens. So this is not the node operators like going in and upgrading the software. It's all fully automatic, decentralized,
Mm.
and it's extremely transparent. So we can look at all these proposals as well. Again, if we go to the dashboard, we look at governance.
So all upgrades are basically mandatory and automatic, and nobody has to do anything on the node side.
Yes,
cool.
They're all automatically implemented. So we could look here. You see all these different topics. So for example, if a subnet had to be updated, this one you see ended with, oh no, so it's a lot more. So 440 million voted to adopt this one, and 0% of voters voted no. Oh, and there's some time remaining on this one, but this one is going to be executed because there's so much of the voting power already assigned to this. And then you could see this one had this payload. So it meant that the subnet here was updated to this replica version. And as soon as this proposal went through, the nodes automatically followed these instructions and updated.
Cool.
That's what I find really fascinating.
That's really nice, because usually like maintaining a node is always like every 2 weeks or every 2 months or yeah, depending on the chain. You get a new update and then you need to test it, and it's a lot of work usually to run nodes.
I mean, I also don't want to lie, because I was part of the very first batch that ran nodes. There was one instance where I actually had to go physically to my nodes in these past 2 years and update and like restart them by hand because something had happened that was not intended. But other than that, everything is totally automatic. My nodes are following the NNS, so this governance system here, and they update themselves. That there's nothing that I need to do or maintain.
That's really cool. And here Ryan asks, currently, how long does it take to cover the startup costs, hardware and hosting to run a single node? So how long are you running your nodes already for?
2 years.
Oh, wow. So you're already profitable, I assume.
Well, yeah. Well, if I had sold the ICP, I would be profitable. Yes.
Okay.
Because I've paid for the nodes and for like the server space and everything. I've paid in US dollars. And then if I had taken the ICP rewards at the end of each month and at least sold some of them, I would be profitable. Now, and maybe we can talk about this as well, but the ICP price has dropped quite significantly since launch and over the past 2 years. So I'm not break even. But if someone were to do the right thing and just get their nodes, and then at the end of each month take a portion of the ICP. So let's assume it's the 2.5x figure. Then you would probably break even within like a year and a few months, because a year and a few months times 2.5 will cover the cost for the 4 years for the hardware. And since if you don't follow my strategy and keep the ICP, I'm just excited about the ICP. That's why I want to keep as much as I can. But if you were just to run this as a node operator and focused on the dollar terms, if you just sold your ICP return at the end of every month or every 2 weeks, after about 1.5 years, you will be break even. And at that point, everything that comes is an extra bonus.
Yeah, let's maybe talk about the price and maybe also the tokenomics. I have here the chart from CoinGecko. So yeah, when it started, it shot up, I think, to the all-time high of $700 on May 10th, 2021. The all-time low was $3.40 in December last year, 3 months ago, and now we are at around $5. So yeah, how do you see? Do you see ICP as an investment, or how would you look at that from the regular like crypto speculation perspective?
Well, for the second question, I probably can't say much, right? Because I don't buy tokens and trade them. Like, I'm a very long-term holder, and I only hold the tokens that I believe have some actual value. So I don't do any technical analysis or anything like that, but you don't need to do technical analysis to look that this is a horrible graph for the project, right? Because it means that some people bought into ICP when it was $100 or more, and now they're down more than 95%. And I can offer some explanations, but I was not responsible for the launch. I was not working at the foundation when we launched. So I don't know exactly how things went wrong, but I think it's pretty clear to say that that was not intended. And the price went way too high, and as a consequence started dropping afterwards. And that, I think, my analysis is it created a negative spiral. The other component that I see is that the internet computer is a slightly different beast, and it's kind of hard to explain. And I think, I mean, we've been talking for 90 minutes, and I still feel we've only scratched the surface of how this really functions and how this really works, and how this is the same as other blockchains, but also in which ways it's different. And so I think that is a huge challenge that no one in the ecosystem has really cracked yet, is explaining the internet computer in very simple and straightforward terms. The DFINITY Foundation, I mentioned it at the beginning, they have about 300 engineers. Incredible organization. What Dom has built is just amazing, both the tech as well as the organization that builds the tech. But since it is so engineering driven and so focused on the engineering of the side of things, you can imagine that those are not, there's just different personalities for great marketers, which we see in other ecosystems, and for people that are really great PhD level engineers to build all this very hard cryptography and make this all possible. So I think it's a mixture of being very unlucky or just not great with the launch and creating a negative spiral, and at the same time not explaining the internet computer really well in simple terms, has led to this kind of outsider position where very few people spend as much time as I do on the internet computer, and thus there's still limited demand in the token. And that's why we see the price kind of jiggle around those $4 to $5, or I think a few weeks ago it was at like $7, but like the sub $10 range. Of course, the bear market didn't help. I think the launch was also 2 weeks before Bitcoin hit $64,000. So it was right at that peak in 2021. And then timing-wise, this was definitely not ideal.
So do users of these applications need to hold ICP tokens to participate in the ecosystem, or where will the demand come from?
Yes, so you need ICP to convert it into the storage, to pay for storage and compute power. So the more people use your application, the more compute and storage power you need, the more ICP you need to buy. Now, unfortunately, this again is like, the IC is almost too good in that aspect, where since it only costs like $5 to store a gigabyte, whereas on Bitcoin, I don't know how much, or in Ethereum, I think it costs the equivalent of like $28 million to store 1 gigabyte. Wow. If you were to write like 1 gigabyte to the Ethereum blockchain in gas fees, it would cost you about 28 million. So it's just like totally different magnitudes. And of course, that also means you don't need to buy as much ICP in order to run these applications. Now, to answer your other question, I totally see ICP as an investment. I mean, a large portion of what I hold is ICP. So that also to be said here, like I'm trying to be objective, but also I am very convinced that this is the way how things will be run in the decentralized web going forward. And that's why I'm excited, or like why I hold the token. I think ultimately we don't need to get to the point where demand really outruns or is higher than supply for people to realize the potential. But we probably need to get to a point where more people look at the IC and say, wow, this actually makes a ton of sense.
Yeah, and there actually needs to be substance. I mean, if there are tons of applications that many people use, then you will automatically have demand for the token as well. And I think it could actually also be a disadvantage to just be the next speculation coin, and then have huge swings, but no substance behind it, right? So I think it's what you are doing. It's the long-term strategy. So you are trying to build the ecosystem, and then with the successful startups, hopefully, will also come the usage. And with the usage, of course, you need the ICP tokens to run the infrastructure, right?
And look, I mean, I've been here for 7 years now, building in the IC ecosystem, and I'm happy to be here for another 7 years and continue to build, because I believe this is the only real answer to how are we going to decentralize more of the stack. and how are we going to create user-friendly, easy to use, good UI and UX all in one stack applications. And that's why I'm here, and that's why I'm sharing my perspective on what makes the internet computer so great.
Are there competing projects that are trying to do the same thing, or is what the internet computer is doing unique in the space?
So I think there's two categories. One is most of the generation 2 blockchains, Ethereum, Solana, and so forth. I think somewhere on their vision, or their visionary statement, they would say something like, yeah, of course, at some point you should be able to host your front end on decentralized infrastructure as well. I think conceptually, everyone agrees that that's the way we have to go. In terms of, so that's the first category that I would say, yeah, I think most of these projects agree that that's the direction that we should be headed at some point. In terms of projects that actually allow you to host things in a decentralized manner, there's a lot less. There's Filecoin and IPFS, which do something similar, although they're, at least my understanding is, you mostly have the storage component. You don't really have the compute component. So you then have to go, for compute, you still have to go to one of those generation 2 blockchains. But those are the two closest that I see to truly decentralized hosting services, if we talk about that component.
Yeah, and let's talk about data storage to understand that, because you said that on Ethereum it would be 1 gigabyte would be super expensive. So is all data stored on chain in the internet computer, or how can I imagine that?
Yeah, it's all stored in one of those subnets. So there's no other place than on chain in the internet computer. Yeah. Everything is on chain.
So basically, the infrastructure, the network of internet computers is basically the internet computer blockchain, right?
Yes.
Okay.
But maybe one interesting difference. So now you might ask, like, how do we make it possible at $5 a year, and Ethereum makes it possible at $28 million, right? Because there's such a stark difference. And there's a few differences. One is storage on the internet computer is not necessarily immutable. So you can update what you've put there. So if you upload a video today, then and you pay for 1 year, if you don't pay for another year, it's going to get deleted. You will still be able to verify that this content existed. So you will still be able to cryptographically verify, even 15 years from now, that this was indeed hosted on the internet computer, but it will not be retrievable, which I personally think is a good thing. You want to be able to prove that something is there, and you want to be able to keep it there. But at the same time, you don't want to allow people to just write things that clearly should not be accessible for eternity, to be accessible for eternity, right? Like there's all kinds of bad content that exists on the internet that doesn't need to be immutable. And a second component is that most generation 2 blockchains, they just replicate anything and everything in perpetuity. So if you connect a new node to the Ethereum blockchain, it's going to replicate every single thing that the other 10,000 nodes, I don't know the actual number, that the other 10,000 nodes already do. The internet computer believes you don't need that high replication to get the safety benefits. There are certain applications that are good enough, that are safe if they're replicated across 13 different completely independent nodes. And then there's other things like a ledger, right? Like where you exchange the tokens, that you probably want to replicate a bit more, let's say 50 times or 60 times. But you probably don't need the benefit that you get from going from 50 times replication to 10,000 times replication is much, much smaller than the additional cost that you get from that. And so that essentially is the answer to how it's done much, much more cheaply. Not everything is immutable. And second, well, there's maybe a third component. Second, not everything is replicated across an unlimited amount of nodes, but there's different levels of replication. And then third, it's also the infrastructure that we're using, right? We're not spending time and energy on a proof of work algorithm like Bitcoin, where the energy is not wasted just on the consensus, but the consensus mechanism that we're using is extremely efficient. It's called a proof of useful work. And if you, I don't know the actual number, but I think it's less than 1% that's wasted on or much less than 1% on the compute and energy on the consensus versus everything else.
And who decides what is replicated how much? So is the developer? Okay.
Yeah. So if you build you can also build something in a way where you say, I want to keep every single state update. For example, like for the ledger, you probably want to keep a transaction that I have sent you a token today. You want to keep that in perpetuity, right? And be able to go back 5 years from now and say, yes, today I sent X amount of ICP to you. So you can set those flags. It's just that they're not enabled for everything by design, by default.
And then, of course, it gets more expensive the more you replicate, right?
Yes.
I would assume. Yeah. Okay.
Yeah.
And then all the data, is that encrypted by default, I would assume, or how does the storage work, or the data
so now
safety?
we're getting into pretty technical details, and I wish I had Seb, someone from my team here. Not everything is encrypted, but it's kind of like, it's similar to what I just mentioned. Yeah, certain things need to be out in the open, right? Like a ledger, you want to be able to verify where tokens were before and how often they're traded and stuff like that. So I think it's the opposite way, where you can set a flag and make something private. Again, using the functionality in these canisters that they can hold a private key. Oh, I see. Seb is actually just saying something here.
Yes, Seb is actually here. So he said, I'd say there are competitors on some aspects, storage DNS, but there is no real other world computer at the moment that is trying to propose all of what the internet computer offers. And then regarding encryption, not encrypted at the protocol level, but can be at the application level.
Okay. So I think the way, what that means is you can hold these private keys in your canister, and you can use that to encrypt the content that you put in the canister. So the canister is able to decrypt it, but no one else.
Yeah, because for example, if you have a messaging app, then of course you need to have all messages encrypted, right? Or yeah, the data that you actually share there. And then he also says, DFINITY is working on a way to encrypt some subnets at the protocol level, coming in the next few months.
Yeah, so this would be one of the improvements that we talked about earlier. Of course, they're never done building the internet computer. This is probably something that's going to continue for the next 10, 20 years. But a lot of the building blocks are currently there in life.
Cool. So yeah, what are you excited about at the moment, or what are the next steps for you personally on your journey?
Well, for me, I'm super excited about this ICP community conference, because it's the first time that everyone in the ecosystem gets together. I mean, you looked at the graph, right? Like we went live in May 2021, so in the middle of the pandemic. And it's just been incredibly hard to build all this and get it live without even having people in the office. So I'm super excited to just bring everyone together in Miami, May 16 and 17, meet lots of ecosystem participants, and talk about like, what are they building and what do they need? How can we all benefit and help one another to make it easier and share this vision of the internet computer?
Perfect. So I think this is a great way to end this introduction. I think it has been fascinating. Again, of course, I've heard about it, but I've never done a deep dive. So it was really good to learn, yeah, from a reliable source what it is, how it's useful, and also how are you, yeah, helping to build the ecosystem. I think it's really great. The vision is worthwhile, and yeah, I wish you all the best, and I hope that you will help create a lot of successful startups and companies on top of that.
Thank you. I'm not going to stop before we succeed. So
amazing. So where can people find you on the internet if they want to reach out?
I'm easy to find, Cédric Waldburger. You find me on all the socials. Twitter is easiest if you want to send me a message or share an idea with me. Also, if you want to build on the internet computer and think you're a candidate for Code and State, send an email to founder@codeandstate.com. Or if you have another Web3 startup and you're looking for funding, then I also run Tomahawk. So Cédric@tomahawk.vc is my email there. But yeah, I don't think anyone will have trouble finding me. So I'm pretty accessible, and I'm always excited about speaking with builders and entrepreneurs. So feel free and find me and come chat.
Fantastic, Cédric. This has been fun. Thank you so much. And yeah, for everyone listening up until here, leave a comment that you made it through. It's always amazing to do deep dives with intelligent people and learn new things. I have learned a ton today. And of course, if you don't want to miss any future videos and interviews in the future, yeah, subscribe to this channel and also like this video. And with that, we'll see each other